All right, we're going to be simplifying some radical expressions. And first we want to make sure that we understand what the terms mean. So the number that's up here outside this radical sign is called the index, and that's whatever root it is. So if there's nothing there, it's just automatically a square root because that's the normal one. And then like if it's got the 3, like you can see the 3 down here, so that means it's a cube root. This is like a 5th root, so those are your indexes. And then the radicand is the number that's underneath the radical sign. So first off, I like to go through and just sort of write down some of the most common perfect squares, perfect cubes, 4th roots, 5th roots. So let's just do that real quick. So our perfect squares, and you might want to just make a little note card or something that has these on them just for a little cheat sheet at first while you're doing these. And so it's just very helpful. Okay, so 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100. We could keep going. And just know that that also works backwards for like 3 squared is equal to 9. So that means the square root of 9 is equal to 3. So those all work backwards. So the square roots of the ones that are in the right-hand column are the numbers that are in the left-hand column. So keep that in mind. Okay, so then let's go to our cube roots, our perfect cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. We could keep going, but we probably don't really need to. So then our 4 powers, things brought to the 4th power, is 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th power is 81, 4 to the 4th power is 256, 5 to the 4th power is 625. That's as far as we're going to go. So then down here, let's write those 5th powers. We don't need too many of those because the numbers grow so fast. 1 to the 5th is 1. 2 to the 5th is 32. 3 to the 5th is 243. And 4 to the 5th is 1024. So remember that when something's brought to a power, that means how many times it's multiplied by itself. So something like 3 to the 5th power means 3 times 3 times 3 times 3 times 3. So you're 5 times, you're multiplying that 3 times itself. All right, so let's go work a few of these. So we have got the square root of 48, and what we're told to do here is to simplify these. So we want to see, is there a perfect root inside here that's under the radical sign that we can take out? Well, 48 is not a perfect square root. It's not in our list over here, but let's think about the factors of 48 and see if we can find one of the factors that has a perfect square in it. So we have 1 times 48, 2 times 24, 3 times 16, 4 times 12, and what else? 6 times 8. Okay, well, looking at our perfect squares over here in our column, we see that 16 is a perfect square. So we can rewrite that square root of 48 as the square root of 16 times the square root of 3. Well, we know the square root of 16 is 4. So that leaves us with 4 square roots of 3. And that is simplified. All right, so now the 5th root of 64. So we've got to come over here and look at our 5th root columns. And let's write all the factors of 64 and see if there's anything that's in there that's under that 5th root power. So we've got 1 times 64, 2 times 32. Oh, 3 doesn't go into it. How about 4 times 16? And then 8 times 8. Okay, well remember, we're looking at under the 5th powers over here. So we see the number 32 is in our 5th powers. So the 5th root of 64 is also the 5th root of 32 times 2. Well, the 5th root of 32 is 2, so we've got 2 5th roots of 2. Simplified. Okay, so now we're back to a square root. Remember, if there's no number in that index, it's automatically a square. So let's think about our factors of 18, and we're looking for any of those perfect square numbers that we wrote on the side. So 1 times 18, 2 times 9, and 3 times 6. Well, the only one that's a perfect square is 9. So we can rewrite that as the square root of 9 times 2 times m to the 3rd power. Okay, so we'll deal with that m here in just a minute, but so the square root of 9 is 3, and we're left with that square root of 2. Now remember, m cubed means m times n. Well, we're looking for that square root. So anytime, if he's got a partner, every 2 of these gets to come outside that radical sign as 1m. Just like the square root of 9 is 3 times 3, so one of those 3's comes out because the square root of 9 is 3. So the square root of like m squared is m. So we'll put that m out here. But this one does not have a friend that he gets to come out with, so he's got to stay underneath that radical sign. So there is that simplified. Okay, so now we're talking about the 4th root. So remember, 4th root, so we're looking over here at our 4th powers, and we're looking for a perfect 4th power that is a factor of 32. So we've got 1 times 32, 2 times 16, and 4 times 8. Well, we see that 16 is in our 4th powers list. So that is the 4th root of 16 times 2 times, okay, let's break that x to the 6 down. We know he's got to have 4 friends to come out with, right? So in order to come outside of that radical. Well, remember when we multiply those exponents, we add the exponents. So x to the 4th times x squared is the same thing as x to the 6th. Well, this one, he's got 4 friends, so he gets to come out as an x, but this one has to stay inside because he doesn't have enough friends. All right, so the 4th root of 16 is 2. Let me make more room here. So we've got 2 for that 4th root of 16. We're bringing out this x to the 4th as an x, and then we're left with the 2 and the x squared. They have to stay under the radical sign because they don't have enough partners to come outside the radical. Okay, so next we have a cube root of negative 64, a to the 6, b squared. All right, well remember, when we're multiplying by negative numbers, you may come over here and look in your cube list and see, well, 64 is in my list already because 4 cubed is 64. So remember that -4 times -4 times -4 would make -64. All right, so you can maybe draw the conclusion that as long as I have an odd number as my index, that I could have a negative underneath that radical sign. Otherwise, we can't, if it's an even number, you cannot have a radical underneath that radical sign. You couldn't have a negative number underneath the radical sign. Okay, so then a to the 6th. All right, I'm going to show you a different way to think about that. So that's a times a times a times a times a times a. Right? Okay, so remember, every 3 of these gets to come out the radical as an a. So here we have 2 of those. So 2 sets of 3. So that's going to get to come outside the radical as a squared. Okay, so we've got -4 is our cube root of -64. A squared is the cube root of a to the 6th. When we're left with the b squared. He needed one more friend, and he didn't have a friend to get to come out with. Okay, so the 5th root, number 6 over here, the 5th root of -32, well, you see 32 is also in my list, so that's going to be -2. X to the 5th, well, he has 5 friends, so he gets to come out as an x. Well, y to the 10th is 2 sets of 5, so y squared gets to come outside the radical. And we don't have anything left inside. So there's your answer to that one. Okay, I know this video is going to get a little bit longer, but because it covers a lot of material. Okay, we're going to go into multiplying and dividing these radicals. So you can only multiply and divide them if they have the same index. So remember, this is my index, the number that it's, or whatever its root is. Okay, so if we've got 5 square roots of 24 times 3 square roots of 8, all right, they're both square roots, so we can multiply them. And the key to multiplying these is to remember, I'm going to multiply what's on the outside. So first 5 times the 3, then we multiply that by what's under the radical sign, so 24 times the 8. Well, 5 times 3 is 15, and that gives us the square root of 192. Well, yes, we still have to simplify this part, and I'm just going to tell you for time's sake that is 64 times 3. So the square root of 64 is 8. So an 8 gets to come out. But what do you do when you've already got a number out there? Well, if he's coming out, and think of that as 15 is times that square root of 192. So we've got to multiply whatever number we come out by whatever is already out there. So 15 times 8, square root of 3. 15 times 8 is 120, square roots of 3. Okay, so now we've got the cube root of 48 divided by the cube root of 2. Well, look at this rule right here. We can say we can cube both of those separately, or we can do the division first and then cube root it. Well, if I'm looking at 48 and 2, I automatically think, well, let's see, 48 divided by 2 is 24. So I'm really working with the cube root of 24. And so when I think of now, I've got to rationalize that. Well, 24 is 8 times 3. The cube root of 8 is 2, left with the cube root of 3. Now, a common mistake that I usually see on students will work sometimes is that you forget to take things outside of the radical sign. So remember, once you take that root of something, it's got to come outside. Okay, or it's not underneath that radical anymore. All right, so let's multiply this one. Fourth root, okay, we're going to say 4 times 8 is 32. A squared times a to the 4th. Remember, we add those exponents, so that's a to the 6th. And then b to the 5th times b to the 10th. Add those exponents, that's b to the 15th. All right, well, let's see. 32 is 16 times 2. And the fourth root of 16 is 2. So we've got 2. I'm going to leave some space here. Fourth root of 2 left. Okay. Now, how many sets of 4 are in a to the 6th? Well, we have one set of 4, but then we have 2 friends left over. Okay. How many sets of 4 are in 15? B to the 15th. Well, we've got 4, 8, 12. So that's b cubed. It comes outside because there's 3 sets of 4, but then we have 3 left over. So there's your final answer. All right, so this is one where I look at it and I say, well, I can't really divide 27 divided by 8. So let's take them separately and say the cube root of 27 over the cube root of 8. Well, if I look on my list, the cube root of 27 is 3, and the cube root of 8 is 2. So that's an easy one. All right, so now you can only add and subtract if the index and the radicands are the same. Okay, that's sort of like having like terms. I can only add square roots of 3 with other square roots of 3. And now we have to remember that when we add these, we only add the outside. So notice, we already have the square root of 3. We have the square root of 3. So that's 2 plus 3, this 3, square roots of 3. And I always think of that as just like, how many square roots of 3 do we have? Well, now we have 5 square roots of 3. So notice that square root of 3 does not change to a square root of 6, which is a common mistake for people also. So don't do that. Okay, so 2 square roots of 50. Notice these are all not the same, so we want to see if we can, if we break them down, what do they become? Well, 50 is 25 times 2. We know the square root of 25 is 5, so that 5 comes out, but he's multiplied with that 2. So 10 square roots of 2. 245 is 49 times 5. Well, the square root of 49 is 7. We're left with the square root of 5. The square root of 125, that breaks down to 25 times 5. Well, the square root of 25 is 5. We've got to multiply it by that 3. So that's 15 square roots of 5. Okay, so this one's sort of tricky. We can only add this term and this term because they're both square roots of 5. This one is a square root of 2. He cannot be added with the other ones. He's not a like term. So we have 10 square roots of 2, and then we have negative 7 plus 15 square roots of 5, which gives us a positive 8 square root of 5. Okay, I'll do these last two because this video is getting a little long. I'll do these last two just on the paper, and those will be handed out to you in your notes for the week. So you can look at those and follow along and see if you got them right. Good luck with this.